being recorded. Please feel free to turn off your cameras. And with that, I will turn the floor over to Ruth. Thank you.
Hello, everyone. Just another quick speaker check. Thumbs up, everything good? You can hear me? All right, great. Thank you so much. This presentation is the first we've done like this for you all in more of an educational format. In fact, it was sort of ironic that right before this call, Jay Chang, who you're going to hear from after I'm done speaking, he said, so are we informing them of what we're doing, educating them, marketing? You know, we haven't, and we really haven't done a lot of, had the opportunity to do a lot of education on resilient communications and how important they are. So I'm hoping that maybe we can access the recording after this as well, and we can use it for some internal education that we need to do. So with that, I'm going to just jump right in and share my screen. And the thumbs up that we're good with the screen share. Okay, great. And you're good with size, I'm presuming. All right, so today's talk is really focused on a really important time frame immediately after a disaster type of an event, and how the communications systems and supporting networks can break down and lead to some pretty life and death type of situations. So I'll start off. My name is Ruth Vogel. I'm with the Applied Physics Lab. I've been at APL for, I guess it's going on 15 years. It'll be the end of this year. And I've been in a variety of positions. My background is actually in critical care nursing and emergency management, but I've done some systems engineer and data science training as well while I've been at APL. That's sort of expected of you while you're there. And then I'm going to kind of set the context, and then I'm going to hand off to Jay, who's going to walk everyone through a sort of use case, if you will, of how we assessed and better understood the problems and the requirements, and walk through his thought process on how he put together a solution. So with that, I guess I just did that. So, and then we'll end with some summary and questions. So with that, this slide is really intended to really set some context and to make sure that there's a kind of level playing field, if you will, of the understanding how important it is, how important the information sharing is immediately after an event, and how if those systems break down, degrade, become damaged, whatever, how that affects all the downstream decisions that happen thereafter. So, whoops, I'm sorry, are we good? Okay, I thought I heard a comment. So if you're working your way from left to right on the screen, you see we go back in time about 10 years. And if you look at the after action reports from the 9/11 events, you would see a lot of reference to that the first responders immediately on scene had had little to no communications capabilities. And you know, it's interesting, we spend a lot of time listening to the news. They love to highlight the fact that the president didn't know what was going on, and the president couldn't talk to the on-scene responders, and he couldn't make decisions. The reality is, for any of these type of situations, the president doesn't make decisions on the on-scene response personnel. So what's happening sometimes that we look at as a national or a global incident, or I should say regional as well. A lot of the media loves to get our focus on, oh, the president isn't up to date, or isn't making decisions fast enough, or he's not deploying resources fast enough. That's really not even his role. When one of these incidents happen, whether it's a terrorism event, a natural disaster, an active shooter, the wildfires, even the pandemic, those folks who are local and their community, that public safety communities, they're the folks who have the responsibility, the immediate, first 12 to 72 hours critical response responsibilities. And so it's those folks who continue to face the same critical communication challenges that we did in 9/11. And we actually did some due diligence in looking at a number of events, 10 up to 10 years ago, and you see the same verbiage over and over again. Communications broke down, networks degraded, wildfires, for example. A lot of the lines actually burned. They lost complete communication during many of the California wildfires. So like I said, the bottom line here is to really set stage for you guys to understand why we focus on a solution that could be deployed to scene. I think there's also a misconception that, the feds arrive immediately, and Jay will talk to you shortly about that. That actually takes quite a while for the federal communications capabilities to show up. So, like I said, if you're familiar with the medical community, you might have heard the critical hour. This is sort of our critical day solution. So, and then this is really one more context slides for you all. So FEMA actually has what they call a National Incident Management System. Are you guys familiar with that at all? Head shake, yes, no, somewhat. Okay, so and I could give a whole 4-hour, well, there's actually months-long training on NIMS, but the essence behind NIMS is that it was supposed to set standards for how we approach, and I shouldn't say it's supposed to, it does set standards for how the public safety community approaches emergency response. And it has everything from very high level response to that describes the 5 phases of the emergency management cycle, all the way down into the weeds, which is one that you're seeing here, where it tries to get a standard out there for what you should be looking for in your communication systems. And so at a high level, these are the 6 key characteristics or key requirements that you should be striving for when, if you're a local public safety community, if you're looking at, communications devices and making decisions about networks, or maybe making decisions about what you're going to purchase to upgrade your system. These are the 6 kind of key things that you need and you should be considering anytime you're upgrading or changing or improving your communications. And I'm not going to read each one. I'm just going to run through them. Interoperability, reliability, portable or mobile, another word there, scalable, meaning you could use it for a small single incident up to a large regional national scale. Resilient, which is our focus today, and then redundant. And so we focus, like I said earlier, on the resilient piece because this is that most critical time for that life and death decision making. And one more just piece from the FEMA NIMS stuff is that you should keep in mind too that although we sometimes use the terms like communications and information and data interchangeably, it's really the communications flow, that I should say the communications flow of the data that leads to active information, and that's what you want for effective decision making. And so keep in mind that when we're talking about communication systems, a lot of times we're talking interchangeably with that terminology. And then I think this is, and so I'm going to hand off here at this point to Jay. So what Jay is going to do then, he's going to talk with you about the process he went through for supporting these immediate, or I should say, coming up with a solution to support the immediate information sharing needs. And with that focus on that critical hour, that critical day timeframe, because as I said, that's what dominoes down the road and can change the whole scope of the response if those immediate decisions aren't handled effectively and efficiently. So Jay, are you good to go? And I'll run the slides if you'd like.
Yes, please. Yeah, my name is Jay Chang, and I've been with APL for, I guess, the past 7 years, working a lot on technical communication capabilities supporting the first responder community. And then prior to that, I was in the mobility industry for over 25 years, basically building, commercializing mobility networks, operating and sustaining it prior to coming to APL. So that's my quick background. And like Ruth mentioned, why is a resilient communication system important, right? So typically, FEMA and other agencies and even carriers have capabilities that that they have designed and usually keep them on kind of a regional location, right? So that it's a kind of a full communication trailer, right? That's capable of supporting various different means of communications. But typically, like I said, it's regionalized. So, the deployment of these things will take some time, and it might take up to 72 hours. In other scenarios, those capabilities can't be deployed into certain areas, like in a wildfire instance where these vehicles can't reach those locations, right? So there are various needs for tactical communications that provides essential communication capabilities to first responders, and it's really designed to temporarily fill the communication gaps, right, until these bigger and more capable communication vehicles, come on scene, right? So it's really to fill that temporary gap between 6 to 12 hours to provide that situational awareness to the incident commander or someone in command, so that can make informed decisions as to how to respond and how to deploy their own assets to address the incident, right? So it's really ultimately, we're talking about a portable capability, right? That really brings a kind of a network in a box with various capabilities that are either built in, and then if there's capabilities where this network can be connected to the internet, so to speak. That's really a what's called a backhaul connection, right? So you can reach outside of that local area network, right? So that you can share information with other stakeholders and access different servers and services that might be essential for response and for the first responder community. Right. Next slide, Ruth.
Just one quick thing. As Jay is talking, just try to absorb what he's saying in terms of the thought processes that he went through and the considerations that he had to give for putting a solution like this together. So he basically went through in a very casual manner some of the requirements that he had to consider in putting this together. So just kind of want to put that out there and make sure that we're all kind of in that same context of learning context of how a technical engineer goes about considerations and development and testing, evaluation, and that sort of thing. So, all right.
That's a great point, Ruth, that basically the 5 bullets here are basically all technical requirements for a system you're developing, right?
Yeah, I mean, it adds to the overall capabilities and requirements that might fill the needs of the first responder community when in a area where you got degraded communications. So yeah, those are kind of the high level requirements that we looked at. Next slide, we'll go into some of the more detailed requirements that we were focusing on in order to kind of target this resilient communication network, right? Which really go ahead. okay, which really incorporates some targeted capabilities, right? So for it to be a capability in areas where existing communication capabilities might not exist or degraded, we're looking at some operational scenarios, right, which will allow this capability to work either on network, right, or off network. And what we mean by on network and off network is, when you're off network, you're not connected to the internet, right? So you're not backhaul connected for whatever reason. And let's say the capability isn't available, right? So when you're off network, right, you still want to have some essential communication capabilities, right, with the technical communication. So when we're designing a resilient system, right, we want to have kind of built-in capabilities that supports communication, right, without even connecting to the internet. Once you have connection to the internet, that kind of expands your connectivity more and allows you to increase your information sharing outside of that local kind of incident area bubble, right? So that remote stakeholders such as emergency operations centers or even hospitals, right, that are involved in that incident can have some situational awareness, in that incident, or with the incident response, right? So we wanted to make sure that it had both on network, right, where you do have backhaul connection to the internet, and off network, where when you don't have it, it still provides some communication capabilities, right? So we thought that was very important. Again, some of the communication services that we wanted to design into a resilient communication network is to be able to, really support, the fundamental communication suites, right, which are voice, video, and data, right? So, we're designing these networks to support those kind of applications. We also wanted to make sure it's modular, right? So, the idea is to, put it in Pelican cases, right, where you can put it in tactical vehicles, right, throw it in the trunk, right, and bring this on scene and be able to set up some capabilities in the incident area, right. Again, it's really designed for tactical use. It's not really designed to support hundreds and hundreds of people, but whatever amount of technical teams they have, upwards of 20, 30 folks maybe, but typically smaller, right? But it's really designed for the tactical, immediate, restoration of communications, when it's degraded or if there's no existing communication services, right? And then really just a flexible backhaul options. So, for the system to be connected to, remote stakeholders, right? And even servers, for example, or databases, it really needs to have a backhaul connection. So, when we're designing a solution, we're looking at multiple different back options, including mobility, including satellite, and various other network connections. And I'll get into the architecture a little bit to kind of give you an illustration of what we're talking about. But that flexible back option really, is beneficial for a technical system, right? And then, various other, later, current state of the art and even future, technology paths, right, including 5G or incorporation of 5G into the solution. Wi-Fi 6 is the latest and greatest, and of course, the LEO, low Earth orbit satellite, communication systems that are coming on air right now. So those things we do see the need to incorporate that technology into some sort of technical solutions. And ultimately, what all this capabilities provide is really, it allows you to bring your own device, right? In other words, this tactical solution provides you an end-to-end data pipe, right? So if you have a device that's Wi-Fi capable, right, you can use the same device with the same applications, right, that's on your phone, So you don't have to learn new applications and how to make a call, how to initiate a connection, right? You're using your standard phone that you've always used, right? And this system is just providing you this data pipe so that you can connect your phone or your device to any services that you're already familiar with. So that's a distinct advantage of a BYOD capability.
Yeah, and
Or
you might be asking right now, well, these are first responders. Why are they bringing their own devices? So when we say, I mean, the reality is they have an agency device, but they also have a personal device. So you could almost do a BYOD times 2. And the reason being, a lot of times, unfortunately, what is purchased by the IT folks or whoever is doing the purchase for these jurisdictions don't necessarily talk to the end users about which devices work well for you, which applications you need. And so sometimes they supplement, and I'm sorry, many times they supplement the agency devices, and by that I mean cell phones, right? With their own personal cell phones. And so so I think that the point here that Jay was getting to is that we take our phones and our communications capabilities for granted. There's, what do you have here? A list of about 12 different really targeted capabilities. These things have to happen in order for our devices, our cell phones, anybody's cell phones to work. So.
Yes, that's correct. So, it's really about flexibility, trying to accommodate as many use cases as possible, right? So the next slide really goes into some of the architectural details, and I'm not going to really go into real specific details, but it illustrates basically, if you look at the left side, right, where you see like the access component, elevation component, that really deals with the end users, right? That deals with the people who actually have the devices, device in hand, either a cell phone or a tablet or even a PC, right? That's trying to connect to some sort of communication system, right? So kind of on the left side, that's kind of the users, right? Right in the middle is what we call a data center, right? Which is really kind of the, heart of the network, so to speak, because it has built-in compute capabilities, data storage capabilities, and local area network capabilities, right? So that really, allows you to install any kind of local applications, right? That allows you to provide the local communication when it's disconnected. So, you guys are, probably familiar with Cisco. I don't know what what your agency use in terms of a telephone system, but typically a video telephone conferencing system such as Cisco, it's really kind of a software solution, right? So what that means is we can install that kind of VTC system, right, inside this data center, right, to support off-network communication capabilities, right, which includes voice calls, video teleconferencing, whiteboarding, chatting, and things of that nature that you might be familiar with already, right? So, and you can install other communication application in that data center, right, to support the end users who are on the left side of the diagram, right? So those are some of the offline capabilities that a resilient communication system might offer, right? And then on the right-hand side in that yellow box is that backhaul component, right? So typically backhaul is provided by some sort of an internet service provider, right? You're very familiar with mobility, either AT&T, Verizon, Sprint, FirstNet, more specifically these days for the FirstNet a network dedicated to the first responder community, right? But in addition to that, there's satellite backhauls, we have the ability to use, tactical fiber, which is about 2,000 feet long, as long as on the other end, we can access a Ethernet connection, right? That's internet routable, right? And then, a microwave wireless link as well, and these, so that it gives you that flexible backhaul capability, right? Sometimes you get what you get, right? Sometimes you have to access, especially out in the field, backhaul options might be very limited, right? So that gives you, at least 4 different options to be able to connect to the internet, right? To connect those end users, right, that are on the left side, right, all the way through to that data center and that out into the internet, right, to engage remote stakeholders, right? Again, access databases, right? So it's rich really for that reach back capabilities, right? And these are, solutions are, open, right? Because, we're utilizing, government off the shelf or commercial off the shelf, right? So none of this stuff is proprietary, right? So that, anyone really can access this technology, right? Directly from the vendors and really, following this architecture model, integrate the different components, right? To provide that end-to-end capability, okay?
Hey, Jay, can you
Yes.
elaborate on which components of this might be government off the shelf?
Oh,
Which
well,
means it would be extensible to say like global partners, right?
yeah, so I mean, so the government off the shelf is actually the software solution that we're using, right, called ATAC, right? It was developed by I think the Air Force, and now kind of commercialized through a third-party vendor. I think it's Parsons. And then, government still has access to that, but the government developed that communication suite, which includes, force tracking, right? Being able to track, for this particular case, responders, right? Visually on a kind of a graphical interface that's overlaid on a map, being able to also communicate through texting, right? And a couple other capabilities that the government provided. That's really kind of embedded into the system, right? Most of your hardware is commercial off the shelf, right? But it's and so I mean, does that answer your question?
Yes, it does. Thank you.
Okay.
And if anybody else has questions, I'll take the liberty of saying, feel free to pipe up in the middle of the talk.
Yes. Yeah, by all means. And we'll of course take questions at the end as well. But if you have any questions, certainly let me know. Okay. All right. So, and then just quickly, we have, we're using FirstNet, and I don't know if you guys are very familiar with FirstNet, but the FirstNet it's actually a very important communication network for the first responder community, because that's really the first nationwide broadband network, right? That's specifically dedicated to the FirstNet, first responder community, right? Before, first responders utilize commercial networks, right, to get the communication services from mobility cellular networks, right? But FirstNet is really a kind of an independent network that's dedicated to them. So typically they have problems with congestion and things of that nature, during incidents, right, major incidents. What FirstNet tries to do is provide relief, right, or prevent congestion by first of all dedicating a network strictly to them, right, and also working through the carriers, providing them priority over everyone else, and most importantly a concept called preemption, right? So that if you're a first responder and that recognize your device as a first responder device, people with lower priorities, such as myself, would be knocked off or put into a different channel, so to speak, so that first responders can immediately access that channel. Before FirstNet, that was impossible. It was really, they had priority, but it was kind of priority and wait until someone drops off, right? So, I mean, that could be a long time, especially during incidents. But FirstNet, now allows first responder to basically preempt other users and allow them quick access to it. So this resilient communication solution also incorporates FirstNet, which gives that priority and preemption to first responders. Okay.
And I think Adam had his hand raised.
Well, okay, go ahead.
Oh, sure. If I can. So I was curious what how difficult it is to train people to use this. And I'm especially thinking if it involves do you have to swap a SIM? Is it just like connecting to a Wi-Fi network, or does it involve like swapping a SIM card or something something else like that?
Yeah, so that's a very good question, and part of that solution that we try to achieve is to make everything simple, right? I mean, a lot of other federal agencies have access to actually communication specialists that might be deployed with some of these capabilities, but first responder community, they don't have such luxuries, right? So I mean, typically, there might be a technically inclined first responder, right, that get defaulted to being the departmental IT communication guy, right? But they really don't have a communication specialist that deploys to an incident with the first responders. So we try to make these things very simple, right? So as long as it's so we have to pre-configure it, right? So that certain capabilities are built in, right? And I'll get into that a little bit later, but we're really aiming to be basically a one button turn on scenario, right? So that at least the end users don't have to worry about switching this on, turning that on, and activating this and that, right? It's really about making it simple, and also giving that data pipe so that it is going to be like a Wi-Fi connection, right? Because as a matter of fact, on this blue side, I don't know if you can see my arrow, on this blue side, it's all Wi-Fi, right? So if you look at that access network component, right, everything's connected to these devices by Wi-Fi. So yes, it's Wi-Fi. As long as you know the SSID and the password, right, and you're authorized to get on this network, then truly you can get on it. And if you have this backup component, you can reach the internet, right? So we try to make it very simple for the end users as well. Okay. All right.
So the switch on is to turn on FirstNet or for the end users to join?
Well, you got to turn on the system first, and the end users would have to know the credentials, right? I mean, we can make that open and Wi-Fi, but then you're going to have people that are not authorized to get on it. Then you might have congestion, so you still have to maintain some sort of credentials. But during an incident, typically, let's say there's a whiteboard, and you can just write the SSID and password if you want, or you can just privately share it to the critical people that might need to be on that network, right? Because you still need to manage. Like I said, it's tactical, right? It's not designed for hundreds and hundreds of people, so you still have to manage people getting onto the network so that you don't overload it, right? Okay. So Ruth mentioned the NIMS, right? National Incident Management System, right? So if we look at that color code that you just saw before, right, with the architecture, it kind of matches that color code in terms of the components. But if we look further down and go down to the National Incident Management System structure, right, you can see that on the left side you got kind of the end users, right, the operators, right, that it might be a tactical team that responds to incident, specific incident location, right? We have what's called a C2, which is that data center, and that's where maybe an incident commander might position themselves, right, to be able to communicate with the operators that are actually responding to an incident, right? And then you got that backhaul component where if you have that component, you can start sharing information, right? So that that remote stakeholders could really get a sense of what's going on, right? So, because they have their own tasks too, to deal with resources and stuff like that. So, they, instead of getting a minute by minute update through a conference call, they can, well, they can, visually see, they can get the, updates, real-time updates through some sort of a communication connection, right? And then, we designed to, go ahead, Ruth, go back. So we designed this to be kind of modular, right? So right now, the capabilities, I don't know, six Pelican cases. And really, we wanted to kind of stack capabilities on top of each other and kind of expand the capabilities. So you start from a very basic capability, and as you, stack different components, you kind of increase capability, increase reach, increase coverage area, so that it gives you that flexibility, right? So I mean, that's kind of the flexible modular approach. Go ahead, next slide, Ruth. And then, like I said, just the overall capability, we really want this to be a one-touch turn up, right? So, basically turning on the on button, right? And then everything else is self-configure and self-connect, right? Well, we do need to provide some physical cable connection, which I'll get into, but after that's done, it's basically one touch turn up, and it's pretty quick in terms of turning up. Like I said, we wanted to embed a voice communication capability, right? A incident area VTC, video telephone conferencing, right? And being able to locate and track first responders, and for incident commanders, right? That's really important to visualize where their resources and assets are, so that they can manage the resources properly in accordance with any kind of incident response, right? And then if we have that back call, right, we can share data so that everyone involved can get that common picture of the incident. Right, so with that backhaul, that provides that, and ultimately, that data pipe, allowing the incident response personnel to kind of use this network, utilize this network using their phone, an application that they're used to, right, to be able to, communicate and access databases and whatnot, right? So those are the capabilities. Simple wire connection, right? Like I said, if you look at the whole system in totality, you're really talking about connecting 1, 2, 3, 4 Ethernet cables with the different components, and plugging it in or turning it on, right? And really, it's really a simple connection. Anyone can do it. It's just a matter of turning on the device, switching on the power. And if you go to the next slide, really we're talking about, go ahead, Ruth, next slide.
And it looks like Adam has another question.
Oh, I'm sorry. Yeah, go ahead. I'm sorry.
Oh, sure. So yeah, so you mentioned like people could communicate using apps that they're used to, but I think probably most communications apps that you use on a day, like most normal ones that you might use for like normal work, have like basically require a connection to the internet, right? Like they don't care that like your IM system doesn't care, like a Teams doesn't care that someone else is on the same local network as you. You still need to be connected to the internet for it. And so is that going to be like, and then I can imagine a lot of them even, like other things like FaceTime, I imagine it's still sending, like it still wants you to connect to an Apple server first. And so you'd still be sending, like if you were going to have a voice call or something, you'd still be sending that through the, some remote server. And that, like, I imagine that bandwidth on whatever connection you have to the wider internet is going to be pretty limited, right? Or it might not be there at all. Is that?
Yeah. So
am I understanding that right?
No, you're absolutely correct. So just quick distinction, on network service and off net service, right? So off net service is through that internally instantiated video telephone conferencing system. And right now, for this resilient communication platform, we, instead of using Cisco, we use a product from NEC, right, which is very similar to Cisco's voice video telephone conferencing system, right? So those require specific applications and clients to be able to use when you're off network. Off network, right? When you don't have that backhaul. So FaceTime won't work. Facebook wouldn't work, and any of the stuff that are based on cloud services wouldn't work, right? But what that BIOD capability provides is once you open up that pipe, right, that backhaul pipe, then you can start reaching servers for a Facebook, right, or a FaceTime or any other, or even YouTube, right. And typically, a first responder might, utilize his device that has what's called a mobile CAD, right? Which CAD is a computer-aided dispatch system, which really kind of it's a tool that first responders use, right? Public safety use to really assign, I don't know, jobs, right? Or assign requests for service. So when you call 911 into a public safety answering point, they start logging, your request, fire, medical or police, right, into the CAD system, and the first responders will get dispatched with all the details. So, a first responder might, use their phone with the mobile CAD application, right, to be able to reach, get that information. If backhaul service is established, right? So that's a very good question. Two different types of scenario, one off net, the other on net, right?
Thank you.
Did that answer your question?
Yeah, definitely. Thank you.
Okay, awesome. So previously we saw, a real simple, like 6-wire connection and then turning of the switches to turn the devices on. The setup time really, the most time it takes is to align the satellite dish, right? And that takes about 37 minutes, right? If we kind of discount that, basically turning up everything else literally takes about 7 minutes, right? So after you plug everything in and turn all the power, switch on the power, it takes about 7 minutes to bring everything up so that you can start, kind of using it. So in totality, it takes about 40 minutes. The bulk of that is aligning a satellite dish, which takes a long time because you're really trying to align it to a real narrow portion of the sky. So it takes time. And then, lastly, go ahead, Ruth.
What is the range of the system and how many users can be on it?
So the range is really dependent on, well, you got two ranges, one on the backhaul side and one on the user side. So if we're talking about backhaul side, right, the range is unlimited for satellite, right? Because, I'd say that with a caveat in the sense that you still need to be able to see the satellite to connect to it. Assuming you can see it, then you can connect to it, right? For the cellular backhaul, right, it really depends on how good the coverage is from the carrier, right? So if you're in like a real rural area where there's no cellular coverage, it might be difficult, and satellite might be a better option. In areas where you have good service and still need this resilient network for whatever purpose, then mobility is a good alternative as well to be able to backhaul, right? If you're talking about the access side, it depends on how high you can mount the transmitter, right? And with this solution, we have a solution that conceptualizes putting the transmitter on a blimp, right? So it takes you pretty high, so that range is going to be pretty big. And we're not looking for 10-20 mile coverage. We're really talking about tactical, right? And maybe 5 mile might be sufficient, right? But it really depends on how high we can elevate the transmitter. Does that answer your question?
Yes, thank you.
Yeah, sure. And then the last slide, just a quick takeaway, what really makes a resilient communication network. We really designed this around a modular design where you can stack different capabilities to kind of, build its capability and expand its reach, like I said, right? So that it's really adaptable for different use cases, right? Fire, law enforcement, or any kind of use. And also, it doesn't necessarily have to be public safety, right? There are other, entities or agencies that might benefit from a tactical solution, right? A temporary solution that really kind of fills a gap until, their big trucks come in, right? Which might be 72 hours later, right? and also you saw that flexible backhaul with the various different options. And if you do want reach back, right? Flexibility is really important because when you're out in the field, you don't have months to plan for providing a fiber optic cable to the system, right? That's not the point of this, because you want quick, resilient solutions, right? Where you can turn up something quickly, right? And that flexibility in backhaul gives you that option to, or attempt to give you that option to provide that connection flexibility as much as possible. Right, and lastly, the ability to work on network and also off network is important, because sometimes you might not be able to get that backhaul, right? So that off network capability is really important. So that built-in suite of communication tools, right, is essential for first responders. Situation awareness and communication where service might be degraded or might not exist, right? So those are some of the resilient communication takeaways. Okay, so if you guys have any more questions, we can certainly answer it.
Yeah, thanks for a great talk, Ruth and Jay. I think it's a lot of really interesting stuff you guys shared with us. I had a question because I'm currently working in this Smart and Connected Communities program at NSF. One of the areas that we fund is in disaster resilience, and it's a lot of kind of similar kind of focused topics and kind of really leveraging digital technologies to kind of respond to disasters and whatnot. One of the things that we tend to focus on in our program is really kind of getting the community and end user input and how the technology is designed. So I'm kind of curious to learn more about, you guys have a very clear end user in this case, which are emergency responders, people on the ground in local communities who would be responding to disasters using this kind of technology to communicate. So what has been the role of the end user, the communities, and kind of helping shape how you've developed the technology that you're working on?
So I'm gonna start because there's a little history with how we got to this point. Great question, by the way. So first and foremost, the general answer is anything we do within our program area, absolutely go to the end users, work with them, get their feedback. This actually came about as a result of working with a variety of first responder communities across the nation over a period of like 4 to 5 years. So DHS S&T actually funded this effort, and they also funded what they called these next generation first responder operational exercises. And what they were doing during these exercises were taking new and emerging technologies directly into their own operational environment. So, so think the county, Harris County, Texas, third largest county in the nation. They set up a series of, and we actually supported it. Jay was actually the technical lead for it. They set up these opportunities, if you will, to kind of go through a series of exercises, scenarios, and things are very, what we call a full-scale exercise or a full-scale event, very realistic. And to see how these emerging technologies, even things like 5G networks, actually provide meaning and support for the decision makers when they're responding to, let's say, a huge hurricane event or a huge earthquake. And the bottom line is what was found unintentionally was, gosh, they don't have the core capabilities to begin with, to let alone bring in and insert some new stuff. So we were essentially, Jay was essentially putting together these systems in Pelican cases, and we were buying stuff and shipping it and taking it ahead of time and setting it up so that they had some core capabilities at these locations to begin with. And throughout the period, there was obviously there was a lot of documentation that's what ultimately led to DHS S&T realizing that, wow, they don't even have, especially during an event, they have no resiliency to begin with respect to their comms. So we have to help them build some resiliency so that, the rest of the stuff can fit in. And I don't know if that answered your question, but that's
Also,
Yeah,
also,
go ahead.
also, we're focusing on first responder use cases for this capability, but that's only because the sponsor that we work with to develop this is really focused on that community. This technology and the need actually transcends more than first responders. If you look at technical communications need, right? Many agencies require similar things with slightly different capabilities, for example, in terms of security, for example, right? But at the end of the day, incident commanders, right, be it DoD, first responder, anyone else, right, requires same kind of situation awareness, that communication connectivity, so that they can make informed decisions from field folks, right, and getting that data and to be able to properly make that decision. So I think it really transcends more than just first responders, right? It has a lot of use cases.
I have a couple more questions, but I let others go before me. I don't want to take up all the question time. Anyone else has questions, please go ahead.
At the risk of being the other person that's taken up all the question time, I was wondering, can you, if you have 2 or 3 or some number of these, can they connect together even if you don't have access to the rest of the internet?
Yes, we didn't work on that specific use case. The plan is to work on scenarios like that for the next phase, if we get authorization to do that. But in theory and concept, yes, you can connect different systems. Yeah.
Oh, cool.
Mm-hmm.
Okay, one question I had was, it's kind of curious, are you guys doing like simulation drills to kind of see real time, how this actually works in like a real time scenario, in an actual emergency?
We did demonstrations of its capabilities. So it's a prototype right now, right?
Mm-hmm.
So it's a demonstration. So the next phase would be to, maybe kind of do a field analysis, right? Doing maybe exercises and stuff. I mean, ultimately the intention is to try to deploy this in real life scenarios. Some communication is better than nothing, right? But we haven't reached that stage yet where we're actually deploying this into a real incident.
And this is just more of a general question, because I've heard about APL, but I'm not too familiar with how technology development and stuff works at APL. So I'm just kind of curious about, this can be something that's broadly useful for lots of communities around the US. You can think about remote communities, you can think about tribal communities. I'm just kind of curious, how that kind of technology dispersion and transfer kind of works at APL. How do you guys think about that? You're developing a great prototype, but then who's responsible for kind of
so it's the government sponsor who's responsible. Yeah, so all of the purchases that we made for this, it's owned by the government. And what you might call this is a prototype system. But the idea was, hey, if we can prove that this can be helpful and in these remote areas and for situations where you have nothing, then the government, there's some government to government handshakes that take place. So I mentioned that this was funded by DHS S&T, Science and Technology Directorate. They are the research and development arm for all the operational components that fall under DHS. So think FEMA, think CBP, the boots on the ground folks. So S&T as an R&D arm will support projects like this. Some very important factors that came from them. This was also affordability, because they know that the civilian side of the government especially the first responder communities, they do not have the deep pockets like the military side does. So, so they, once we're done with it, well, we are done with it. We actually just finished this up. We hand it back to them, and now they're, you know, they hope to take it and provide it as a capability to the operational customers that they support. So does that make sense?
Mhm.
Okay.
So it seems like it's kind of incumbent on federal government staff, such as us fellows, to help make these connections for different applications, which is why we're here today.
Yeah, I mean, we've, it has a lot of potential applications. I know that S&T has to go through some tech transfer processes on their own. But we have also made some connections for them to start talking to folks from FEMA. I know Jay and Liz have actually done a lot of briefing on that path. So thanks.
Well, we are actually at time. So thank you all thanks to our speakers for participating today, and for everyone else who listened in. At some point, we will post it on our TBD DiG page, and then you can come back and watch the recording later.